We are working on ChemQuest number 14, titled Trends in Size. So let's look at our information. Now notice the title has shielding written right here. So that may be a new term, maybe something we need to pay attention to see what are they talking about when they say the word shielding. So here we have some Bohr diagrams. Remember that the scientist Bohr is the one who said the electrons were in energy levels. And so you see here the first energy level has 2 electrons. All of them do. And then the second energy level is a little bit different because each one is different. So boron, we have 3, which gives us a total of 5 electrons, which is how many boron has. Carbon has 6 electrons. And nitrogen has 7 electrons. And notice they're also telling you a charge. Here we have a +5, a +6, and a +7, which is telling us how many neutrons they have. Okay, so let's read our information. Because the nucleus is positively charged, it exerts an attractive force on the electrons. However, the 3 electrons in boron's outer energy level do not feel the full +5 attraction from the 5 protons in boron's nucleus. Before the +5 attraction gets to the outer energy level, it gets partially canceled or shielded by the 2 electrons in the first energy level. The 2 electrons in the first energy level weaken the attractive force by 2. Therefore, to the outer energy level, it feels like only a +3 charge rather than a +5 from the nucleus. Okay, and then look at carbon. An electron in the outer energy level only feels a charge of +4 coming from the nucleus because the 2 electrons in the first energy level shield 2 of the positive charges from the nucleus. So there's a +6 in the nucleus. And then these 2 shield 2, so these outer 4 only feel a +4. Okay, so let's look at our questions, see if we understand this information. How large is the charge that the second energy level of nitrogen feels on the nucleus? So we're going to talk about nitrogen because boron and carbon were already talked about. So how large is the charge, the second energy level? So the first thing we need to look at is the charge in the nucleus. What is the charge in the nucleus? That is a +7. So these 2 here are going to shield 2 of that, leaving us a +5. Okay, so let's get back to our question and see if we can write up an answer. All right, so nitrogen's second energy level. Now I already know I'm talking about nitrogen because it's in the question. So I'm going to say the second energy level feels a +5 from the nucleus. The total +7 charge is weakened by 2 electrons in the first energy level. All right. Why does the first energy level in each of the 3 diagrams only contain 2 electrons? Now this is knowledge that we already know. So it only contains 2 electrons because that's all it can hold. So the first energy level can only hold 2. All right, How many electrons can fit in the second energy of any level? This is review. The second energy level can hold 8 electrons. That's review from one of our very first chem quests in this unit. How many electrons can fit in the third energy level? Once again, review, 18 electrons. Okay, now we're going to talk about aluminum. How many energy levels does aluminum have? And how many electrons should be in each energy level? Aluminum, if you look at the periodic table, has 13 electrons. So when you draw the diagram, you're going to put 2 in the first. The second one, I'm going to put 8. That gives me 10. And then I'll have a third energy level that has 3. So how many energy levels does aluminum have? 3. Now I had to do all this just to be able to answer the question. Well, there's other ways you can find the answer, but that's how we did it right now. How many electrons should be in each energy level? Well, by my drawing, I've answered that. We've got 2 should be in the first, 8 should be in the second, and 3 will be in the third. Question number 6. Draw a Bohr diagram for aluminum similar to those in the information section above. And I did that in the last question, and I have redrawn it right there. So that's what it should look like. I put a plus 13 in the middle because that's just reminding me that aluminum has 13 protons in its nucleus, and I know it's a plus 13. I'm going to need that to answer the next questions. Number 7, explain why the second energy of aluminum only feels a plus 11 attraction instead of a plus 13. Okay. So the second energy level is shielded by these 2 electrons. And so it only feels a plus 11. So basically you've got your plus 13, and then it's being shielded by these 2 electrons. So that's giving us a plus 11. So we can say the plus 13 charge gets weakened by the 2 electrons in the first energy level. Okay. Number 8. How large is the charge that the third energy level of the atom feels? Okay, so we start with a plus 13. And it's shielded. I don't know how we want to make that sign for shielded. Let's just draw a line. Shielded by the first 2 electrons. So now we're at a plus 11. The plus 11 is then shielded by 8 electrons. So now we are at a plus 3. So the answer to the question is plus 3. The plus 13 charge is weakened by the 2 electrons in first energy level and then the 8 electrons in the second. All right, so now we have some new information to look at. Charge and distance. As you know, opposite charges attract. Examine the following diagrams of charged metal spheres. So in diagram A, we've got a plus 3 and a minus 3. that seem far apart compared to the other two. Diagram B, +4, -4, and they're a little closer together. Diagram C, +5, -5, and they're really close. The attraction between the two charged metal spheres in each diagram is represented by an arrow. The metal spheres are pulled closer together in diagram C because of the +5, -5 attraction. This attraction is stronger than the +4, -4 in diagram B and the +3, -3 in diagram A. So it looks like the higher the charge, the stronger the attraction, according to the information. Electrons behave the same way as the metal spheres are depicted in Figure 2. Consider the Bohr diagrams of boron, carbon, and nitrogen in Figure 1. Recall that boron's outer electrons feel a +3 attraction from the nucleus. Carbon's feels a +4. And in question 1, you found out that nitrogen feels a +5. This attraction between the nucleus and the outer energy level determines the size of the atom. If the attraction is strong, the atom is small. That's a really important point. So let's highlight this. This attraction determines the size of the atom. If the attraction is strong, the atom is small. If it is weak, the atom spreads out and is larger. So, if the attraction is strong, the atom is small. In order to be strong, you have to have protons. So it seems like if you have more protons, the attraction, your atom is going to be small. If you have less protons, your atom is going to be larger. All right, let's look at our questions. Which atom is larger, nitrogen or carbon? And then, of course, why? So nitrogen, if we remember, has 7 protons. You look back at your diagram on the first page. You've got nitrogen has a +7. Carbon has a +6. So nitrogen, we've got 2 in the first energy level. In the second energy level, we have 5. And then carbon, we have 2 in the first, and then 4 out here. Okay, so let's think about what's going on here. There's a +7 in the middle of that, and a +6 in the middle of carbon. So these electrons feel a strength of a +5, and these electrons feel a strength of +4. So which atom is going to be larger? So the larger atom is going to be carbon. And then, of course, we have to answer why. Nitrogen's pull, is +5. Carbon's pull is +4. Nitrogen's electrons are pulled closer together. Nitrogen's electrons are pulled closer to the nucleus. Which would make it smaller. So you want to really remember this point right there that we highlighted. The attraction between the nucleus and the outer energy level determines the size of the atom. If the attraction is small, if the attraction is strong, the atom is small. If the attraction is weak, the atom is larger. So carbon was weaker than nitrogen, which means carbon is the larger atom of the two. Number 10. In a silicon atom, the force of attraction from the nucleus to the outer energy level is +4. Using a Bohr diagram of a silicon atom as an illustration, explain in detail why this is true. The first thing we have to know to be able to draw the Bohr diagram is to know how many protons does silicon have. So we pull out our periodic table and we need to find silicon. And it's right here, number 14. So it has 14 protons, 14 electrons. So then we have to draw the Bohr diagram. So I'm going to put a +14, so we remember that. The first energy level has 2 electrons. The second energy level can have 8, and I'm going to pair them all up. 2, 4, 6, 7, and 8. So that's 10. So we have 4 more. So I'm going to separate all of them because they're really not paired together. All right. So there's our silicon. So let's put Si so we know who we're talking about. Using a Bohr diagram of silicon atoms, explain why this is true. So it says that the outer electrons only feel a +4. So let's start with what we have in the middle. We have a +14. This +14 is shielded by 2 electrons, making it a +12. Those +12 are shielded by 8 electrons, leaving us with a +4. And that's how we get our +4. So how do we say this? Well, pretty much how I wrote it, but let's see. Let's say the +14 is weakened. We'll say it how we've said it before. By the +2 in the first energy level the +8 in the second leaving only a +4. Okay, let's look at our next question. Draw Bohr diagrams for sulfur and chlorine. All right, in order for me to do that, I need the periodic table. I need to get the number of protons. So we're looking for sulfur. Sulfur is number 16. And then chlorine is number 17. Okay, that should be easy to remember. Okay, so there are the 2 Bohr diagrams. Sulfur has 16 protons and chlorine has 17. So let's see what we have to answer about these. (12A) Find the size of the charge attraction between the nucleus and the outer energy level for sulfur and chlorine. So sulfur, its outside electrons are going to feel a charge of +6, and chlorine, outside electrons are going to feel a charge of +7. And if you don't understand how we got those numbers, just rewind and watch the explanations for the examples that we've already done, because we don't want to keep explaining it when we've already explained it. And plus, we usually have to explain it again anyway. So the question, though, that we need to figure out is which one is going to be larger. And you got to remember what the highlighted statement said in our last information. Which atom do you predict to be larger? So this has, sulfur has a +6 pull, chlorine has a +7 pull. So because of that, sulfur is going to be the larger atom. And of course, what do we have to do? But explain ourselves. Explain that. So I'm going to write the explanation. Okay, so sulfur has a weaker attraction than chlorine, which means sulfur's electrons will not be held as tightly, making sulfur larger and chlorine smaller. All right, let's look at question number 13. Notice and compare the locations of boron, carbon, and nitrogen on the periodic table. Now compare their sizes. Do the same with sulfur and chlorine. There is a general trend in size as you proceed from the left to right across the periodic table. What is this trend? In other words, how do atoms in the same row of the periodic table compare to each other in size? All right, so here is the periodic table, and there's boron, carbon, and nitrogen, and they're together, and they are in period 2 as we go across from left to right. And then sulfur and chlorine are in period 3 as we go across from left to right. And this doesn't have the periods number, but I know that's 1, 2, 3, 4, and so forth. So think about the sizes, and we need to come up with a statement that explains what is going on. So the statement we can say is, as you go from left to right across the row in a periodic table, PT for short, the size of the atom decreases. Star this question because that statement you have to know. All right, we have some more information. Bohr diagrams and the size of atoms. Examine the following Bohr diagrams of 3 atoms from the periodic table. We have atom A, B, and C. Notice that C, of course, is smaller, but one thing that I notice is in their outer energy level here, they all have 1 electron. So that's something that I notice. So let's look at our questions. Okay, so we need to find out the name and the atomic number of each atom from figure 3. So at this point, it's just a matter of counting the dots. We know those dots are electrons. So atom A is the first one. So if you count all the dots, you've got 10, 11. You've got a total of 11 electrons, which means I also have 11 protons. So the atomic number here is 11. And then atom B, I have 3 electrons, which means I have 3 protons, so the atomic number is 3, and atom C is 1. Now the first one I know without even looking at the periodic table. That is hydrogen. Atom B has to be lithium. It's number 3. And be looking at your periodic tables while we're doing this. Number 11 is going to be sodium. All right, that was easy. Considering atoms A, B, and C, what is similar about their location in the periodic table? So if you look at hydrogen, lithium, and sodium, they are all in the same group. They are in group 1 of the periodic table. That's that 1 right up there. So number 15A, we can say that they are all in the same group or the same column. In atoms A, B, and C, compare the force of attraction from the nucleus to the outer level of electrons. Okay, so if we look at sodium, it has 11 protons, and it's shielded by 2, giving it a plus 9. This plus 9 is shielded by 8, which gives us a plus 1. All right, and so lithium, you have a plus 3. It's shielded by 2 electrons. Then we have a plus 1 left, and that's the outer electron. And our last one is hydrogen, which is plus 1. So it looks like they all feel the plus 1 attraction. All right, the next question, number 16. In figure 3, atom A is larger than atom B. The attraction between the nucleus and the outer level electrons is equal in atoms A and B. So what other reason would there be for atoms A's larger size? Propose an explanation on the structure of atoms A and B. So we can say that atom A has an additional level of electrons. Each additional level increases the size of the atom. So this is a question that is important. Question number 16. Each additional level increases the size of the atom. So every time we move down a period, the atoms are getting larger. Number 17. Draw Bohr diagrams for neon and argon. In order to draw Bohr diagrams, I need to know how many electrons they have. So here's neon and argon. Neon is in period 2. I don't have these numbers written over here, but very easily can write them in. So neon is in period 2, and it's got 10 electrons. And argon is in period 3 and has 18 electrons. So a lot more electrons and an additional energy level as well. So let's get these drawn. So here are the Bohr diagrams for neon and argon. And you can see that argon's got that extra energy level, so it makes that atom a little bit larger. So make sure you have a periodic table that you're looking at so you can understand the answers as I do these questions. What is similar about the location of neon and argon in the periodic table? Well, basically they are in the same column. Or you could say group, which is number 18. Okay, question 18b. Compare the force of attraction between the outer level electrons and the nucleus for neon and argon. Okay, compare the force of attraction between the outer level electrons and the nucleus for neon and argon. And basically the force of attraction they feel is a plus 0. And I've written the explanation down here in C. So we just do what we've been doing. We start out with a +10 with neon. The first energy level has 2 electrons that's shielded, ends up being a +8. The next energy level has 8 electrons that shields it, and so the outer electrons feel a +0 because it balances each other out. Same thing with argon. You've got the +8 and then 8 electrons, so they feel the same, +0. So using your answers to 15b and 18b, what can be said about the elements in the same column and the force of attraction between their outer energy level and the nucleus? So we can say elements in the same column have the same attraction between the nucleus and the outer level electrons. So question number 19, and here's one of our key questions. Which is larger, neon or argon? And then why? Why is that one larger? So, argon is larger. And basically because argon has an additional energy level. So number 20, in general, there is a trend in sizes of the atoms as you move down a column of the periodic table. What is this trend? So basically this trend is as you move down a column, atoms get larger. So this is a key point. So you want to make sure you highlight this, and this is something you need to know. And then question 20, ask the why. Why does this trend exist? So to explain this, going down a column also means the number of energy levels are increasing. Increasing the energy levels causes the atoms to be larger. So once again, this is a key point, key question here. This information is important. This explains what question 20A said. As we move down a column, atoms get larger. So typical questions, once we know this information, are like question 21. Order the following list of elements in order from the smallest to the largest, or it could ask you to do it from the largest to smallest. So the first one, 21A, potassium, arsenic, and bromine. So the first thing you have to do is get a periodic table and look at those three and where they're located. So we have our periodic table, and I've highlighted potassium, arsenic, and bromine. So you need to remember what is the trend as we go across a period. Do the atoms get smaller as we go across or larger? So we want to arrange these from smallest to largest. And if you remember the trend, as we go across a period, they're getting smaller. So bromine is going to be our smaller atom, then arsenic, and then potassium. So you write that in the right order. Bromine is the smallest, then arsenic, and potassium. Our next three are phosphorus, antimony, and nitrogen. So let's look at the periodic table and find those three. So we have phosphorus, antimony, and nitrogen. So as we go down a group, we have a different trend. Atoms get larger as we go down a group. So antimony is going to be the largest. Nitrogen is going to be the smallest. So let's go back to our question. And then we need to put them in order from smallest to largest. So the smallest is nitrogen. And then phosphorus. And then the largest would be antimony. All right, and so the last ones, we have sulfur, calcium, magnesium, and chlorine. So let's find these on the periodic table. There is sulfur, and then magnesium, calcium, and then chlorine. So out of these four, you need to say, list them from the smallest to the largest. So we have magnesium over here. So calcium is going to be bigger than magnesium, which is going to be the biggest of all of them. So you basically know that calcium is the largest. So that answered the one that goes on the end. And then we're going to say chlorine is the smallest, because chlorine is smaller than magnesium. So now we're kind of working backwards, going from chlorine, and then sulfur would be bigger than chlorine, and of course magnesium is bigger than sulfur, and magnesium is smaller than calcium. So it ends up being chlorine, sulfur, magnesium, and calcium.